Welcome to Season 10 of the Prosthetics and Orthotics Podcast. This is where we chat with experts in the field, patients who use these devices, physical therapists, and the vendors who make it all happen. Our goal? To share stories, tips, and insights that ultimately help our patients get the best possible outcomes. Tune in and join the conversation. We are thrilled you are here and hope it is the highlight of your day.
Hello, everyone. My name is Joris Peels, and this is another episode of the Prosthetics and Orthotics Podcast with Brent Wright. How you doing, Brent?
Hey, Joris. I'm doing well. And, here is something interesting. And I know you love the seasons thing. We're going into season 10.
Okay.
But what
Excellent.
that means is this will be the 109th episode. And that's a lot of episodes. And we're still having a good time. It's been
Totally.
over 2 years, learned a lot. And so, yeah, I'm really, really excited about that.
Totally. Me too, man. Me too. So who's on for today, man?
Yeah. Well, so today we have Adam Hecht from Dive Design. And then we'll also probably get into a little bit of his company, Decibel. And then he also does prosthetic stuff for pets. And so
that's cool.
We've got a lot to talk about. So Adam is the one that actually made my chairs for the podcast when I was at AOPA. So the 3D printed chairs, he has one of the Caracol robots. And so some really cool stuff, do some really innovative stuff with 3D printing. They push the boundaries of not only materials, but then you'll love it because material extrusion, big time. They don't do a lot of stuff on the side, but they really push the FDM side really, really hard with what they're doing. So I'm really excited to catch up with him. Just truly a nice dude too. I met up with him. Actually, it's been a couple shows now, and we just had a good conversation. So I'm really looking forward to continuing this on and seeing what else we can learn from him.
Awesome. Hey, welcome to the show, Adam.
Thanks so much for having me, guys. I'm really excited to be here.
So first off, how did you come into contact with 3D printing?
That's a good question. The short answer is I went to study industrial design in college, and 3D printing was a major component to that. It was a big tool that we used throughout the process of creating products. The slightly longer answer as to how it became my entire life today is it actually started years ago, I think 2012 or so, 2010. I think I was in middle school, and my mom was a pediatrician. My dad was a industrial designer. And, I was always fascinated by both the design world, also the medical world, working, with people directly. And I saw a TED Talk, and everything just sort of clicked in that moment. It was by Scott Summit. I don't know if you guys are familiar with him, but he was one of the first people to really
love Scott, dude. Scott is a friend, and I love him very much. I think he did so much to make prosthetics beautiful, actually, and as well as functional. And a lot of stuff in 3D printing. So I really, really love the guy. So awesome that he inspired you.
Yeah, absolutely. It was that moment I was like, holy crap, this is the perfect blend of, creating beautiful art, products in the physical world, but also getting to directly impact someone's life. And it kind of touched on both for me. I was like, I'm going to do something like that someday. I don't know how, but it seems like the technology, the design, the healthcare side, that's so important. And then when I went to school for industrial design, because I leaned a little bit more on the design side than the medical side, my sophomore year, my industrial design program, or the entire school merged with a medical school in Philly. And all of a sudden I got to study the best of both worlds and get very involved in the 3D printing side as well.
Well, that's super cool. And then, one of the things you guys do, I've heard of all the stuff you do. You do chairs and you do all sorts of industrial design projects and stuff. But the thing I think you do that not a lot of people have really dipped their toes in is this kind of this medium format or large format 3D printing. So we're talking usually it's extrusion based. We've got gigantic machines, which are either robot based or gantry based, making things from what we call medium formats, like a meter to a meter to a meter, and then large format is bigger than that. So tell us a little bit about getting involved with these larger systems, because I think it makes a lot more possible people maybe have not really considered.
Yeah, absolutely. It's been very exciting to get finally to the large scale. But, we started small, right? When we were in college, we started the business, we were doing freelance, and we sort of bartered our way to get our first little Dremel desktop printer. And it was just sort of a gradual process of working our way up. We knew we wanted to do big things. We wanted to have an impact, and it also coincides with having a large machine. You can do, far more with it that's not possible on a smaller scale with the same type of machines that everyone else has. And so it's kind of like we traded our way up, right? We got the first desktop one, then we got a slightly larger one, then we got a medium format. It was a WASP 4070 industrial printer. That's where we started with the prosthetics. And then we went slightly larger again to Filament Innovations, one of their large format machines. And then finally got up to the robot as the projects grew, as the need grew, as the applications, got more interesting. So it really was a very gradual process. We've always been within the extrusion realm, I think primarily because of the accessibility of it, especially from the beginning, right? Being able to start with one machine and then just add on slightly larger. It was a very scalable journey. And I think that's what enabled us to get there.
Okay, so and if we're talking about like the Filament Innovation type of machine, which is, we talked to a bunch of people from them. It's basically a high flow material extrusion system, but kind of looks like a supersized version of whatever you have on the desktop, but a lot more metal, I think, than those things. When you're designing for those kind of things and the much, much bigger objects, is there a lot more that you should think about or that you can consider, or is the design really different?
Yeah, absolutely. I mean, the Filament Innovations machine is a great starting point. It's almost like a gateway drug to a larger format and, printing with pellet. But when you do make that jump there, I would say physics really starts to play a larger role. You're really concerned with gravity. You're really concerned with thermal dissipation as the layers cool and sag and do happens with the smaller machines, but almost on a microscopic scale, whereas it's so amplified. You have to design the tool path as you design the part. I mean, that's just how intertwined they are. It really becomes a huge factor as we design for these larger systems.
And if we're looking at like even larger, like the robot arm type system, which of course you could put on a gantry, you can make much larger things even than a few meters. Does it change again, or does it just get a little bit more extreme?
Yeah, I would say that's where the largest jump is. That is where it is most extreme, where we're most concerned about layer cooling, we're most concerned about geometries. But the interesting part, though, and what makes it so unique, obviously the reason it's a robot, not just a gantry machine, is that we have all of the other axes to take advantage of. So yes, despite the fact that cooling and overhangs and travel moves, all of those little things that we consider with smaller machines becomes so amplified, we can do things that we can't do on a desktop machine. We can basically print in ways that eliminate overhangs, whereas you would need a ton of support material on a standard machine. So we can sort of get around some of those roadblocks just by running a multi-axis print where the layers stay normal despite curvature. So we can basically curve parts or do non-planar layers or we can print onto a mold, for example, so that we don't need a removable support structure that needs to be printed every time. So all of these new freedoms are unlocked with it, despite the fact that, yes, it is a little bit trickier to go from a 500 gram per hour extruder to a 25 kilogram per hour extruder on a system like this.
And one thing I've noticed about you guys, and I remember seeing these planters you made and stuff like this, and there's a couple other designers out there that do this, but they make, using kind of desktop printers, they make things that look a lot more mature, a lot more beautiful, I think, than just what regular people, kind of more makers and more industrial type people make. And of course, part of that is like, yes, I'm a designer. That's kind of what I do. Are there any kind of things that we can take into account, that people take into account to make more beautiful and also more functional kind of material extrusion, like FDM objects?
Yeah, I think it comes back to how we think about designing something for printing, right? In the past, you design an object, you bring it into the slicer, and the slicer does its best job. It takes its best guess at how it should be sliced, how the G code should be created, and how it should treat the corners and the walls. And you get some ability to program that in the slicer, and then it's off to the machine. Whereas when we design products that are intended to be made via additive manufacturing, via FDM, you really have to cut out that middle step. You have to bring the design of the part so much closer to the actual machine and the process itself. It's almost like you're cutting the slicer out. Of course, we still use slicers in many cases, but you really have to design the tool path as you design the part so that You bring what's inherent with the process, the layers, the curvature, all of the benefits we get from 3D printing. You have to build it into the part rather than just hoping that the slicer takes its best guess at how to convert it for you. And when you have that direct line of communication with the machine through your design of the part, you can start to really take advantage and create those really beautiful. I'm sure you've seen the lamps, companies like Wooge and all these brands around the world that are getting into actual home goods and other products with FDM. I mean, it's really because they're cutting out the slicer and they're designing the part in the way that the robot would see it, or the printer itself. And that makes such a difference.
Yeah, and I know you can use like full control and stuff like this to do this. What kind of tools would you use to work with just like on a G-code level with the machine?
Yeah, the biggest is, I would say, Grasshopper. That's really where people, I think, started in many ways in creating G-code. It's very powerful in terms of being able to write, a custom script based on a design without needing to convert it into, something in something like Cura or a Bamboo Slicer, for example. So Grasshopper is a powerful one. And of course, you can use the standard slicers. It just takes designing with the limitations in mind, right? Making sure that, if you're designing for 1 millimeter nozzle, your walls are a multiple of 1 so that they don't get squished and compressed, within the walls of the part, and it leads to artifacts and whatnot. So you really have to understand what leads to the issues with the prints. And you can design around that for a standard slicer. But when you're designing the toolpath itself, you're almost, it's the printer becomes an extension of your mind, right? You really have to be in tune and connected with it.
Yeah, and I think that's a really I think a really elegant way of saying it as well, because it's almost as if like before people were just designing it without designing it, let's say, and be squished by the printer, kind of like you said as well. And now it's kind of like actually designing it with the constraints. Like you're a painter actually paying attention to the paintbrush rather than drawing and then hoping it'll come out with whatever paintbrush you could find yourself with. So I think that's a really good point. And, let's talk a little bit about are you looking at large scale assistive devices? We talked a couple of times, for example, about things like scoliosis braces and bigger assistive stuff. I mean, you guys seem to have the ability to do that. Have you looked at that kind of thing as well?
Yes, we have in the past, more so than we have today. I mean, after we launched 3D Pets a few years back, we had a lot of interest from the human world as well in terms of doing custom devices, things that were more challenging to make conventional processes, just like we've done for the animal prosthetics. And so we were fairly involved for a little bit using our medium format machines to do everything from custom hip disarticulation sockets to scoliosis brace prototypes to printing, entire legs that would be hard to cast otherwise for thermoforming. So we've done a lot in that area. It definitely wasn't our focus. It was fun to be involved and to help, move the needle for some other clinicians and practices. Today, it's certainly something that we still enjoy, but just not something that we've been able to focus too much on with the prosthetics brand in the animal space, which has really been our primary focus.
Talk a little bit about how you got involved with this 3D pet stuff, because I think it's really cool. And we talked to a couple of people involved in this stuff, and it's kind of overlooked, but it's such a nice place to experiment. And so how did you guys get involved with that?
It's a good question. Now, we got involved, I think I might have still been a senior in college when we started the business our junior year. So, we were lucky to get the ball rolling with some interesting projects and opportunities. Somebody I met, I think it was my freshman year of college I went to some tech event and I met this guy, Sean Walker. He was basically printing prosthetic feet in his basement. And he actually didn't know how to use CAD. What he would do is he would import a cube into the slicer and he would turn off the walls and he would just print the infill. He would print these essentially lattice patterns and he would thermoform them to create really interesting designs that you really couldn't make any other way. And he would mold them and he would create these really elegant, like custom prosthetic feet that were modular. He was just doing all this amazing work. He was winning hackathons and, he was partnering with all these other designers and prosthetists. And it really caught my eye because that's obviously what had got me so interested in the first place, getting into industrial design school. We stayed in touch. I was able to learn a lot from him. And then one day he called me and he was like, "Hey, I just got a job building exoskeletons in Seattle, but I have a few unfinished projects I could use help with." And one of them was for an animal prosthetics company that was building, I don't even remember what it was. It wasn't a prosthesis, it was some other device. And we were introduced, we learned more. And the guy that we met was like, basically spent 2 hours just telling us about all of the problems, all the challenges with making the devices, and how he would lose money on each device he built, but couldn't not offer them because there were dogs that needed them. He couldn't keep up. It seemed like a nightmare. And us, just getting started with this design studio, we were like, this is such an interesting opportunity, a way to bring what we've learned from the 3D printing space, the design space, and really see what we can do here. Because obviously animal prosthetics is slightly different when it comes to some of the regulations and testing on some of the barriers that you have in the human world. And so we really got to come in with an open mind and see how we can make a difference. And it started to work out. We made our first prototype, it worked, and one thing after the next, it led to an entirely new brand.
And how come this guy was losing money on all these things he was making initially, and how did 3D printing change that for him?
When you're building, to imagine just building like Scully brace after Scully brace, right? These huge molds, super time consuming, one guy building them. But he's also doing hundreds and hundreds of braces and smaller orthotics and partial limb prosthetics. And so when you have to drop all of these, very fast, high volume products to make something that takes, 10, 15 hours of doing plaster and carving and, pulling thermoplastics, do a check socket, then to bring it back and to do a carbon fiber socket, and the alignment doesn't work and they have to rebuild it because it's a dog and you can't really assess it the same way as a human. Like, each device is taking 15, 20 hours to make. And we're talking about primarily a full limb replacement, right? This is a device that has to go around the torso of the dog in order for it to stay on. And so it was just so much hand labor that disrupted the development of all these other faster products, higher volume products. And so, it was impactful. It worked, but it just wasn't sustainable. And so what we did was we came in, we took a look at the process A to Z, and we looked at how we could create something that was entirely digital, right? Instead of molding the dog, can we use a scan? Instead of pouring plaster, can we just work off the scan in 3D? Instead of designing each one from scratch and only having one guy do it because he's the master of all, well, could we just build an algorithm to automate the design process? So instead of hand fabricating it and tying up one guy's time, can a machine print it overnight? So, we just went through step by step and found the alternative process that would enable it to be scalable, that would enable us to do it on our end. And that was really the goal, for us to be able to produce these for him so that he wouldn't need to even worry about it, other than just, handling the customers and doing the fittings, which was his dream for that product. And so honestly, we didn't really know if 3D printing would be the answer at the time, but it was sort of like, we didn't know what we didn't know. And we were stubborn and said, let's just try it. And we were thankful to start with a small device, a very small cart. But before we knew it, the guy was taking orders and had asked us to be on his episode of a TV show he was filming. We were still working out of a basement at the time. And so I very quickly put a fire under our asses to, one, figure out the product, but two, move out of my partner's parents' basement into a real space. And, it was really how we got things started.
So I think that's really interesting, because it seems like somebody had a pain, right? And is super focused on a solution. Can you take our listeners, a lot of our listeners, they may be scanning, but they're not 3D printing. They may be scanning or they may not be scanning at all. Can you give them maybe some just baby steps or some things to think about as they are looking at potentially bringing this into a practice, and how you guys potentially how you guys focused on solving one problem that then opened up avenues to solve other problems?
Yeah, absolutely. I mean, our methodology, our approach from the beginning, and not that this was some strategic decision, it was that we didn't have a choice, right? We always start with the simplest possible solution. We had no funding. We had no capital work, but we didn't even have a budget from this company. So, when we make decisions, we always have to start with what's most accessible. What can we do today? What can we do for $50, or what can we barter? What can we trade? So that's how we made decisions when it came to machines, when it came to scanning, when it came to software, when it came to everything. And we were working with, a machine that was given to us out of a sponsorship deal. It was not something designed for printing pet prosthetics or anything. Frankly, it was an entry-level machine. When we looked at scanning, we were like, what's the cheapest scanner we could find? It was like an original structure scanner that mounted on an iPad, or like an old iPad. I think my partner probably found at a recycling center. When we looked at the software for making and designing these, we're like, what's the only free software you can work on modifying scans for? And it was Mesh Mixer, which we still use today.
Joris, my goodness, he's gonna come unmute and talk how awesome.
Nothing. No, I mean, I'm just saying it's the most, everything runs on Mesh Mixer. So I think
of course it's not even developed anymore. It's like extinct, but it's still like something we use all the time. I mean, so it's what we had access to. I certainly didn't have any capital to pay for any other software, and I'm glad we didn't, because we did the most with the least. And that's what everyone else can do. You don't need to start with the most expensive machine or software or tool. It's incredible what you can do with the bare minimum, how much you learn, and then can decide, which machine to invest in or which software to invest in once you have context, right? It's really hard to start without the context of all of the different machines. Because, I mean, when you look at machines, it's not just which brand do I get, right? It's like which technology, which material, what size, what do all these like specs mean? It's stressful enough to pick out a new computer, let alone like an entirely new method of creating something. It's overwhelming. And that's why our guiding, voice in all of this is like, all right, what's the cheapest thing to start with? And then we move step by step as we need to, but not until we have to.
Well, I think I like that because it does, and I think what you said, context, I don't know that we've ever heard it in that way, but the context of what you're trying to do, what can you do for the least? And that then becomes a springboard for what you like really want. So if you're trying to get faster or you need something better, you now have the ability to say, this is where I started with my free software, and maybe I spring for something that is very focused to get you rolling. So that is great advice, Adam.
I appreciate it. Yeah, I mean, it's otherwise it's risky. I mean, that's why everyone I think is afraid to take the jump, the plunge. I mean, there's risk involved, whether it's capital being spent on a system that you don't know. One, will it do the thing you want it to do? And two, will it break? You need maintenance? Will it become outdated? But the third biggest variable is time, right? The time to learn something new, the time to get started. It takes away from what you're already doing, what you're comfortable with, what's already working in many cases. And so unless it's something that you're making a real commitment to do, or it's a passion project, it's a hobby to start, something you do on the weekend with your kids as you learn this together, because it's something that everyone I think can benefit from. I wish I had a 3D printer when I was a kid. I was always building stuff in the garage. I was always working with my hands. But had I had someone in my life that had one and was learning it themselves, like that would have been the coolest thing I could imagine. And so I think when people start to realize that it's so much more than just a tool for the O&P industry, I mean, this is a disruptive technology. It starts to seem a little less scary and a little less like the technologies of the past.
Yeah, and I'd love to share for you to share a little bit of your journey. I mean, you've started to diversify, but it's still very niche, right? So you've got the 3D pet stuff, you have the industrial design side of things for the diode designs, but then you've also kind of spun out this Decibel. Is it Decibel made or just Decibel furniture? Okay, Decibel. And can you like those chairs were awesome. I love what you're doing, but can you also just share kind of the market for that? And then also you've got the technical, like that is really cool for furniture, but then you are also fighting this like that's not traditional furniture mindset as well. And I'd love to hear your perspective on that, specifically with Decibel.
Yeah, well, let me take a step back real quick, just so that it starts to make sense as to why we do prosthetics, why we do furniture. What the heck is going on here, right? We got into starting the studio in the first place because we wanted to make impactful products and brands using new technologies. And that was really, really vague when we started out, right? We kind of went into it with this open mind of like, we don't know what we're going to do, what we're going to work on. All we know is we want to make an impact and get to use the latest and greatest tools. And what that turned into was this focus in additive manufacturing. Because as we looked at everything, and we weren't even focused on 3D printing when we started the business. It was just a tool that we used. But when we had that first prosthetics opportunity and realized, holy crap, 3D printing is not just a tool for prototyping. Like, this is disruptive. Like, this is enabling products that previously couldn't exist. That's where it really started to shift for us. And we decided that we wanted to focus on accelerating the adoption of additive manufacturing, making products more sustainable, more tailored, and more accessible. And so that's really what we look at everything we do. We look at it through that lens of can we do that and can we have that impact? And I think 3D Pets was the first big one, right? Making a product certainly more tailored, certainly more accessible. It's not exactly high volume. Sustainability is measured there, but we were certainly able to have an impact. We've done over almost 700 devices in the past few years, whereas people were getting turned away before that. There was one person that could make one or two a month. It really wasn't a scalable product, and that was really exciting. And so as we built Dive, the design studios, we worked with other companies helping to solve their own problems using these same tools and methodologies. I would say the next pattern started to emerge, the next opportunity to have that same impact. We had been doing a lot of commercial furniture projects, whether they were for furniture companies or technology companies building out trade show booths. I mean, we really started to see a need for more sustainable solutions. I mean, we were learning about the millions and millions of tons of furniture that's thrown out every year lands up in landfills. The fact that 95% of plastic also ends up in landfills. We were seeing these incredible production systems when we would go out to trade shows in Germany. Huge robotic systems building everything from boats to furniture to other things. Out in Europe where we weren't seeing the same in the U.S. And we said, all right, it's time to take that next leap and start the next brand that we really see that we can make an impact in. And that was, of course, Decibel, and making commercial furniture more sustainable by using these circular production technologies and doing it in a way also that's more accessible, not from a consumer standpoint, but also from a designer standpoint. We're primarily industrial designers. We know what it's like to work in that industry and to be at the mercy of the very few manufacturers that there are out there, right? I mean, manufacturers are the bottleneck for designers to be able to create products and have their own impact. Whereas with 3D printing, it really democratizes that. And so, the mission for Decibel is, of course, making the products more sustainable, more circular, more tailored, but also giving access to the designers to have that same impact. We actually don't really design many of the products for Decibel. Most of them are co-developed with designers around the world. We're working with brands in New Zealand, Germany, Australia, the Netherlands, the US, all across the country, co-developing these pieces because we can. We're not restricted to tooling. If the design doesn't sell, it doesn't sell, but there's no risk to anyone. So, it's been a really cool journey in getting to support the designers, but also the industry overall from a innovation standpoint, and helping to move the needle for quite frankly antiquated, really out-of-date, old-fashioned industry where they've just done things how they've done things for decades. It just kind of felt like it was time for some change.
I love the kind of like the can it be done cheaply ethos, and also the kind of the kind of bootstrapping and keep on bootstrapping thing, and also this kind of the idea like, okay, maybe it doesn't sell, oh well. And do you see that as being like core to your business? I mean, now it's a very difficult time for funding, for anything from bank loans to VC. But maybe a business like yours doesn't need that. Maybe you just keep on building it and you end up with a profitable company. Is that much more like in what you were aiming to do rather than some sale to somebody or something like that?
Yeah, absolutely. I mean, especially right now, right? We're not totally sure what the future holds and the direction we'll take then. But the reason we started with a design service rather than a product was because we knew it would be scalable. We knew that we could start with $200 in business cards, going to networking events, getting some design consulting work, freelance and whatnot. We knew we could start there, and we knew we could grow that. And we knew it would be, services obviously aren't always the most consistent, but at least it enables control, right? Like, we can go out, we can get business, we can keep the lights on. We can build a team of resources. So we have industrial designers, engineers, and we have all of these talented people that we work with now that, yes, obviously help to support the design studio. But when we launch new products through 3D Pets or through Decibel, we already have those people ready to go. They're already, they know how it works and they know what we're doing. And so it became such a valuable resource to have this central studio that's enabled us to, one, self-fund the products, which products always obviously take longer and more upfront investment, but two, to support that, to build new products, to improve things, to make things better, and to continue learning. Many times we get to learn at the expense of our clients. We have people hire us for things that we would never anticipate printing, that we get to learn a ton about with the different technologies and tools and materials. Throughout the pandemic, we actually did a lot of work in the additive manufacturing industry. Companies would hire us that were building new materials and new machines and new software. They'd hire us to figure out what to do with it. They'd say, hey, we have this new material. How can it be used in robotics? How can it be used in automotive? We'd go out, we'd find companies that could potentially utilize them, help them get started. And then we do projects around that for trade shows so that other people could learn from it, so other people could see how it works. And that was a really fun position to be in because we got to learn ourselves. And we also got to kind of help move the other industries forward by educating them.
Yeah, I think that's a really, really cool example. And I think it's also really nice entrepreneurship, very different than what we're seeing from years where people are just like, kind of like, I want to build this company so I can get out. It's very much, I'm in it until I find someone dumber than me with more money. It seems like a more kind of some way more honest, more lifelong business model, maybe even a lot more, to what business used to be like, kind of, rather than what they kind of became. So that's good, right? And are you any what kind of stuff are you working on? Because the thing with that I think is most exciting about you guys, you can do almost anything, right? You can make a lampshade, you can make a boat, whatever, you know what I mean? But also filtering that is really, really difficult. I think, when do you say no, or when do you pick what you want to work on next?
Yeah, it's a really good question. We do have to say no a lot. We've gotten better at it. When you start a business with absolutely nothing, you learn to say yes to everything, right? It was like the superpower we had when we started was say yes to everything. We figured it out. That was, I think, what, taught us so much was just saying yes to whatever we could. I mean, we did everything. And I'm talking like before we even graduated, like first months, we had done everything from prototypes for inventors and, multi-tools and grill cleaning products to like websites and graphic design. It's like we designed a barber shop in South Philly. Like never anticipated doing that, but we learned to figure it out. We learned to just say yes to opportunity. And so many of those random projects just led to so much growth, even if it was learning what not to do again, right? Like that was just as important. And as we really built a footing, as we really figured out where we wanted to go and focus on, which obviously was the 3D printing component, we did have to start to learn to say no and to turn down certain opportunities that weren't in line with that vision. And it was really hard at first. It was always kind of an argument between my partner and I, like, should we do this? Should we not? We need the money, but it's really not moving us in the right direction. But as we started to filter, I think the impact started to get clearer. We started to get more of the projects that we really wanted to do. And those would lead to more projects in that same area, which really started to compound. And so I would never say that I regret saying yes to everything. It was super valuable, but it was just as invaluable when we learned to start saying no and started to take on the right projects. And there was a period where, we would take things on, not really knowing if it was a good fit for 3D printing, but we were going to learn together. And worst case scenario, we had become conventional product development studio. We had been designing parts for injection molding and CNC machining and, all of these different conventional tools. The fallback was just to design it as it needed to be. We would never just push something to be printed because that was what we did. We always tried to take the path that made the most sense for the project, the product, the client. And so we always tried to maintain that even when we were doing the marketing work, as we were doing more of the consulting in the additive space. And we always tried to remain as technology agnostic as we could because the impact we wanted to have was actually having an impact, actually seeing the success of products, actually, helping to move the needle and find the right fit rather than just using something, using FDM because we had FDM in our studio. Right? If it didn't make sense, we used MJF, we went to injection molding, and that's something that we still maintain as much as we can today.
So I do have a question, but I don't exactly know how to ask it. So one of the things that Joris and I talk about a lot is outsourcing where you can and live in your strength. So like you guys are living in the strength of, we have all this kind of knowledge, tribal knowledge now, moving into the robot stuff, pet stuff, that sort of thing. Can you explain so let's say I'm a prosthetic and orthotic company and I want to get into 3D printing. I have no experience. And do you take that on yourself and learn it all? Or where does the value of like a dive design come in that you can actually, I don't know if measure is the right word, but does that make sense? So it's like, yes, so if I was to bring in 3D printing, it'd take me a year. But if I bring in dive design and say, hey, I want to do, this, and this, and it takes 2 months and I have a product to sell, that there's a lot of value there. Do you have, like, when you're, for lack of a better term, pitching to people that may come up to that and say, hey, we might do it internal, but we might use you. How do you pitch that to them to be like, hey, we have a lot of value, and that value you're going to realize much quicker?
Yeah, absolutely. I think the first important thing to do is differentiate. So whether you're working on a product or a project or just adopting a new process, because each of those categories is very different. And I think we really learned this with Decibel, because we originally started with offering a catalog, offering products. And when architects and designers realized, wait a second, like, you don't have an MOQ, you can do all these things we can't make with, molds and machining, and, there's no upfront cost for that. Wait, can you make this random part that I have, or this reception desk, or these shelf? Like, can you do all of these one-time projects that are constrained by conventional manufacturing, because you can't really do one thing at a time very easily? And we started to realize it's not just products that the opportunity, it's also projects. And you have to think about that in a totally different way, because a product is a lot of work up front. It's a lot of prep to get it ready. But then the expectation is that once it's done, it's done. You just make it. You make hundreds or thousands, whatever that is, whether it's furniture or something else. But with a project, a lot of the time it's a one-time, like, hey, we need a reception desk that looks like it's made of ice. It's just for this one customer. We're never going to make one again. And so for us, the value isn't the production over time, paying back that initial design effort. It's what they're paying for is the design effort, right? It is all of the upfront work. It is the one part. And so we have to manage the time differently. We have to build a project differently. It's an entirely different type of scope. And I think that applies also for any industry, right? So it's something people have to ask themselves, whether they're making reception desks or prosthetics. Is this a one-time thing that you're reaching out about because you just can't make it by hand? Like, you need a very complex, large brace or prosthesis that you can't figure out how to fabricate. And this is a one-time project, and you don't want to have to learn all the tools and learn all the processes just to make this one thing, versus this is something that I want to develop, bring into my workflow on a day-to-day basis to be able to, grow with this over time. And whether that's just for a repeatable process or for developing a product, like you see an opportunity to make a better bracket or adapter, whatever that is, it really comes down to the individual at that point. Like, do you want this to be your first product or your last? Do you want to get this done and, somebody that knows the technology, knows the industry, and you trust, and you want to reap the benefits of investing up front and having a product that continues to sell? Or do you really want to learn this so that you can continue to create your own products and continue to enhance your own processes and let this be something that grows and compounds over time because you're earlier in your career? So I think those are the important things to consider when you are considering getting help or outsourcing or finding another manufacturer. Is this a one-time thing, or is this something that you're looking to do a lot of and really want to spend the time to learn? On our end, we work with companies in all different ways, and it kind of keeps it fun. There are times we get to just sort of disappear and develop a product and have full control over that. But there are times that we work very closely with companies and manufacturers and even orthotists and prosthetists, still helping them to do their own custom devices and products. And they're a lot more involved in the process because they want to be. And so it's just a matter of, what are you looking to get out of it?
And I think that's a good point. Like, and it sounds like some of that definition, like what you were saying, is how much time do you want to put in to build the next thing? So is what you're looking to build on itself. So it's kind of like what you guys are doing with Grasshopper is you're investing the time and effort to do tool pathing in Grasshopper instead of buying, say, an off-the-shelf package that is, that you're going to be forever using. But, you investing that time now, that becomes your intellectual property for the future, no reoccurring subscription, that sort of thing. And that's what's important to you, at this point in time. So I think that's a great perspective, is if you put in the time, you will also gain, to me, it's even better than patents, the know-how, how to do things and stay ahead of your competition.
Yes, absolutely. I mean, you're really, it's either time or it's money, right? You can pay more and get it done quick, get it done right. Or you can not pay very much, but you're investing time, right? You're learning on your own dime, you're learning on your own time, your own dollar. You're going to make mistakes and you're going to learn a lot from that. And there's a ton of value in that, but that's not valuable to everyone, right? If you're not intending to ever use any of that, if it's just a one-time thing, or it's something that, you're just focused on the product and not the process, it doesn't matter. The time is a lot more valuable. You'd probably rather spend the money, but again, everyone is different. Everyone's, objectives and path. And I think there's certainly a route for.
Yeah. I mean, there's a bunch of lessons I wish I wouldn't have learned.
Definitely do. Oh, but anyway, so hey, thank you so much, Adam, for your journey into your company and your way of doing things and stuff. I think it's really illustrative, and I think really a lot of people can really learn from that. So thank you so much for your time today.
Absolutely. Thank you so much for having me, guys. It was a lot of fun to chat about, and this was great.
And thanks for being here as well for you, as always, Brent.
This was great. Yeah, Adam, and it was so good to kind of hear your perspective on business as well, and like really long-term business too. And I think that's refreshing for us to hear, especially in this kind of environment of additive manufacturing. So digging in, learning, building new stuff that there's a demand for, I think that's great. So thank you.
Absolutely. Well, I really appreciate it again, guys. It's been a really fun journey. I love to share it. Like you said, we're not just looking to make a quick flip and sell the business. It's truly something that we enjoy. Love also to see other people get started in a similar way. So thanks again, guys.
Awesome. And thank you for listening to another episode of the Prosthetics and Orthotics podcast with Brent Wright and Joris Peels. Have a great day.
And that's a wrap for another episode of the Prosthetics and Orthotics podcast. A special thanks to Adam Hecht for sharing his expertise and journey with us. If you enjoyed this episode, please kindly leave us a review. That would mean the world to us. If you want to catch up with us, please join us on LinkedIn and give us a shout via direct message. And until next time, we'll catch you on the next episode.